wrong page. There we go. All right, so previously, before today, we were graphing equations that were in this first form. And you'll notice the letters A, C, D, E, F. There's something missing, okay? Today, we're going to graph equations that are in the form of A, B, C, D, E, F. The term that was missing before is a term that has both X and Y in it. So when we did things like complete the square in the previous equation, we could do that with the X, putting the X's together. We could do that putting the Y's together. But now we can't do that because of this XY term. So what I did is I went to Desmos and I typed in the new equation and I just made sliders for all of the letters and left all my X's and Y's in there. And I just made all of my sliders equal to 1. So basically there's every single term just with a coefficient of 1. I'm going to turn it on. And you can see that this is an ellipse. But what's special about the ellipse that's different than what we've been doing? Yeah, it's rotated. Okay. What I'm going to do is I'm going to turn off the B. I'm going to actually not turn it off. I'm going to put the B at 0. So there isn't a B term. There isn't an XY term. I'm going to make that B 0. And now the conic is straight up and down and vertical and horizontal. Like the two axes would be vertical and horizontal. But as soon as we have the B in there, it's going to start rotating it. And if I rotate it far enough, can you guys tell what happened? Oh, shoot. If I rotate it far enough, can you tell what happened to this graph? Is not an ellipse anymore. Can you tell what happened to it? Nobody knows? I think it went through a parabola and then went to hyperbola. And it only goes up to 10, so that's as far up as I can go. And then I can go the other direction too. So B term is rotating it. If we don't have the B, there's going to be no rotation. I can change other stuff. Oh, I'm like zoomed out. I can change other stuff, and it's going to change what kind of graph we have. But if we don't have the B, then it's not rotated. Okay. We can see what different things do if you're curious. Does anybody know what the F is going to do? Do you want to guess what the F is going to do? Shift it where? Oh, okay. And I wonder if that is different if I have other values going on. I don't know if that's different if other values are going on. Let's see. Ooh, look how fun that is. Okay, sorry. Having too much fun. So today we're dealing with the BX term. You can't just graph the way that we've been doing it with the BX term because you won't be able to complete the square and have those two little squareds with the X's and the Y's because the XY goes together. So instead, what we can do is we create a new plane. So what I have here is I have an XY plane. Okay, you see the XY plane. And then what I'm going to do is I'm going to rotate this XY plane however much. And that X and Y axis are now going to form a new axis. It's going to form a new plane, which we're going to call the X prime, Y prime plane. So in black, I've got the XY plane. And in blue, I've got the X prime, Y prime plane. So I just took all the stuff that would normally be on black and then I rotated it all together. This is how we're going to deal with these rotated conics. After the rotation, we will have, and you don't you don't really have to focus on this so much, but we will have an equation that gets rid of the b, x, y term. And it's left with just the a, c, d, e, and f. So we don't have to worry about the x, y. We can now do complete the square and put these in the right form for us to graph like vertices and asymptotes and stuff like that. This right here is a box that shows 2, 3 very important formulas that you need to know for converting an equation that has the bx term into an equation that's missing the bx term. Okay, the first thing that's important will be cotangent 2 theta is equal to a minus c over b. So we're going to use that. And then right down here, we got 2 other pieces of information. We've got x equals x prime cosine theta minus y prime sine theta. And when I was originally doing my notes, I just like went to old habits, and then I had to go look at the notes a little bit carefully. The y equals x prime sine theta plus y prime cosine theta. Like this one does not have the cosine first, and it doesn't have the y with the sine. Like it's a little different than what we've done before, so just be careful. They're a lot like the things we've done, but not the same. So those are the 3 things that we're going to use. We have 3 examples today. So we're going to do rotation axis for a hyperbola, for an ellipse, and for a parabola. I have purposely given you an entire piece of paper. I zoomed in really far last bell that I didn't even use the whole piece of paper, which is fine. Okay. If anybody is doing this on regular paper, it'll probably take like a piece of paper each. That's what it took me when I did it on regular paper. Okay. And it depends how big you write. I write kind of big. Okay. So the first thing we're going to do, this equation has an xy term in it. Okay? Has an xy term in it. So we need to get rid of the xy term. We need to change this equation. I'm going to start out by just listing A, B, and C so that I can fill out cotangent 2 theta is equal to A minus C over B. So in this equation, A is next to x squared. We don't have one, 0. B is next to the xy, 1. C is next to y squared, 0. So I'm going to have 0 minus 0 over 1, so 0. Cotangent 2 theta is 0. So now I'm going to solve for theta by first thinking about where is cotangent equal to 0? If you have an answer, please speak up. Otherwise, this is going to take forever. What? Oh, 0 and 180. No. Yeah, it's 90 and 270. Now, we do not need 2 answers. We only need one of them. So I'm just going to usually pick the first one because it rotates to that one first rather than going to 270. But you can pick the other one. A lot of the work's going to look a little different, but in the end, we should still have the same picture if you pick the other one. I'm just going to stick with picking the first one, okay? So 2 theta is at pi over 2. So where's theta? Pi over 4. So we just solve for theta and we get pi over 4. So that's our theta. So now I'm going to use the second piece of information that I color or put a box around in that previous page. The formula x is equal to x prime cosine theta minus y prime sine theta, and y is equal to x prime sine theta plus cosine oops, y prime cosine theta. I'm going to plug in pi over 4 for theta. If you are writing less than me, then find the cosine at that theta and make that your next step, which is going to be my next step. So for both x and y, we are finding cosine pi over 4 and sine pi over 4. They're just in different places, and one of them has a different sign. So this should be somewhat easy. What am I doing? Not the right question. Getting distracted. Okay. Oh my gosh, I am getting distracted here. So now when I was working through this, when I was practicing it myself, I compared to the book to just make sure I'm doing things right. And they actually did not rationalize. And I was like, well, let me see. I'm going to leave mine rationalized. And I was working it out rationalized. It's easier to not have it rationalized. So instead of square root 2 over 2, they used 1 over square root 2 for both of these. That's equivalent. It's just not simplified, but that's not the directions. It's not to simplify this. The directions is we're trying to find an equation. So then for my x, I'm just going to combine the fractions and have x prime minus y prime over square root 2, and y would be x prime plus y prime over square root 2. So this is giving me a conversion equation to go between the two planes. X would be in the xy plane. X prime y prime would be in the x prime y prime plane. So we can convert between the two planes. If we need the x value, we use the first one. If we need the y value, we'll use the second one. Okay? That's what I'm finding with this right here. Okay, our next step. We're going to substitute xy in the original equation. The original equation was xy minus 1 equals 0, I think. Yeah. So my x value, I'm going to substitute with x prime minus y prime over square root 2. My y is x prime plus y prime over square root 2 minus 1 equals 0. I'm going to multiply that out. So on top, multiply binomial times binomial. On the bottom, square root of 2 times square root of 2. I'm going to get x prime squared minus y prime squared over the square root of 2 squared. Does anybody know why I did not get a middle term when I multiplied these two binomials? Conjugates. Conjugates? Yeah. The difference of squares, they're going to cancel out the middle term. So if you notice that ahead of time, then you've got a little time saver there. Okay, the directions of this question say to write it in standard form. So that's what I'm doing right now. They also tell me this is a hyperbola. So to be in standard form, I need to move that 1 over. And I need to have the x and y as separate fractions. So I'll have x prime squared over, and then square root of 2 squared is 2, minus y prime squared over 2. So this would be the answer to their question. We're going to do more than just answer their question. So our standard form for this one is with x prime and y prime, because we couldn't do standard form with the other one. And what I mean by standard form is like standard graphing form. There's like different standard forms. I'm talking about standard graphing form where you can pick out, what can we pick out from this? Center? What's our center? Okay. What else can we pick out? Let's say that was your question to graph. What could you find? The vertices. So if we had to graph this and we needed to use the vertices to graph it, would the vertices be on the x's or on the y's? On the x because it comes first. And I would use, well, a squared is 2, so a would be square root of 2. So from our center, we would change our x's plus or minus square root of 2. The endpoints of the conjugate axis aren't vertices, but they're those other 2 points that you just draw before you make that rectangle. Those would be plus minus 2 on the y's. And I'm saying y's. This is in the x prime, y prime system. So this is not like normal, but we'll graph it. You'll see. And then the other thing that we would want to do is find our asymptotes. And that would have to do with putting the A over the B or the B over the A, just depending on which way it was going. This one would be B over A because the Y is with the B. And it would be plus minus. So what would be my slope if I put B over A? Right? So it'll be plus minus 1x, or just x. It passes through the center so that our y-intercept is 0. You can also get that from graphing it. So that's what I'm going to do next is graph. So what I'm going to do is I'm going to use color when I do these so you can kind of keep track. I'm going to use black if it is the XY system. Perfect. I'll use black if it's the XY system, and I'll use blue if it's the x prime, y prime system. This rotated how many degrees? Or how many radians? I don't care. Pi over 4, which is 45. So my new x-axis, that was pretty accurate there. I was trying to make it exactly 45. I don't know if you guys know that that line you can do that with the lines. Oh, this one's not going to be as good. It's pretty close. Okay. So my vertices are at plus minus square root 2, which square root 2 is approximately 1.4. So what I'm going to do, oh, let me label this too. Let's see, the x-axis, the y-axis, and then this will be x prime, and this will be y prime. So what I'm going to do is I'm going to look at labeling the blue ones, you know, counting by ones. Trying to make it accurate. but I'm freehanding it, so it's not going to be perfect. And it looks like 1.4 is where I'm going to go on the X prime axis. And then on the Y prime axis, I'm also going to positive and negative 1.4, but those aren't points. Those are just the numbers that help me make that box. So now I'm going to make that, what's it called? Rectangle. Actually, it's a square for this one. So the asymptotes in the blue system is like plus minus x, up 1 over 1, starting at 0, 0. So if I'm turned, so I'm looking at the blue system, and I go up 1 over 1, up 1 over 1, up 1 over 1, it's the y-axis. That's the asymptotes. And you can see the y-axis is passing through the corners in the center. The x-axis is passing through the corners, unless you didn't draw your graph very accurately. Which is why I was trying to draw mine really accurately. And then I can use those asymptotes to graph my hyperbola. There. So I've got my hyperbola graphed. So one more thing I want to talk about is in the XY system, what are the vertices? And what are the asymptotes? So I changed the color back to black so that I can keep my colors organized by which system I'm talking about. Plus I wrote the words XY system. Let's start with the asymptotes. In the XY system, what lines are the asymptotes? So the asymptotes are these. So in the XY system, it's the two axes. So y equals 0 and x equals 0. In the XY system, what are the vertices? So I'm gonna draw these in big black dots here. So we're gonna find those ordered pairs, but in the XY system where I'm gonna go over however and then go up however much. I'm gonna find that ordered pair. Okay. Now I'm gonna do that. Sometimes I can use the picture to do it, but sometimes I want to use these X and Y converters that I drew earlier, that I wrote down earlier. So that's what I'm going to use. I'm going to use these. All right, I'll just copy them down here. X equals X prime minus Y prime over square root of 2, and Y equals X prime plus Y prime over square root of 2. And I'm going to take the vertices that were at positive radical 2, 0 and negative radical 2, 0. And I'm going to plug them in. Oops, I plugged in the negative first. Sorry. There. I'm going to do a separate time for the negative square root 2. So the vertices in the XY system, after plugging it in there, I get x equals 1, y equals 1. 1, 1. Then I get x equals -1, y equals -1, -1, -1. So that's what these points are here. Okay, this question only asked me to find this, but so this was going further past that just to show you where we're using those equations. Go to what, hun? The vertices? Yeah. So now we're going to move to example 2. Oh, yeah, we found information and graphed it. Just more practice on graphing so that when you have to graph, you have had experience. Okay, are there any questions about anything on this before we go on? Like, I had a lot of questions in my other class. You don't know what to ask? Yeah. Okay, well, we're going to keep going. And then if it's a question that the next one answers, that's great. If not, try to think about how you can word a question so I can answer it. So the next one, they're already telling you it's for an ellipse. So we kind of have an idea of what our equation is going to look like. This says sketch the graph. We're going to find our equation and sketch it. Okay. So the first thing we want to do is just start with what's A, B, and C.
So A is the x squared.
Mm-hmm. So A is the x squared, the coefficient for the x squared, so 7. B is the xy, so -6 square root 3. And C is the y squared, 13. So I'm going to plug that in. 7 minus 13 over -6 square root 3. I get -6 over -6 square root 3, which gives me 1 over square root 3. And by the way, 1 over square root 3 is square root 3 over 3, if that helps you at all. But I'm going to write it as 1 over square root 3 because it just is like one less thing to think about when we're doing all the multiplication and all the algebra. So my next question is, if the cotangent of 2 theta is at square root of 3 over 3, then what's 2 theta? So where is the cotangent square root of 3 over 3? Where? It is not pi over 6. Anybody else? What? Gracie? Yeah, it's pi over 3. It was a 50-50 on that one, huh? So now if 2 theta is pi over 3, then what's 1 theta? That one's pi over 6. Okay, so we know the angle that it's rotating is only 30 degrees. So now I'm going to find my x and y conversions. So I'm going to do x prime cosine of pi over 6 minus y prime sine of pi over 6. And then I'll also do, my y is x prime sine pi over 6 plus y prime cosine pi over 6. I'll find these two answers. So cosine pi over 6, this is what I was doing last time. Square root of 3 over 2 minus y prime 1/2 And that means the other side is x prime 1/2 plus y prime square root of 3 over 2. So for x, we're going to have square root 3x prime minus y prime over 2. And for y, we will have x prime plus square root 3y prime over 2. And as you guys are finishing to write that down, I'm just going to write our next step is use original equation and substitute x and y, not just the xy, but. So this is where we're converting it to the x prime, y prime equation is where we substitute. That's my original equation. So the first thing I have is 7x squared. So I'll have 7 times, that's my x, square root 3x prime minus y prime over 2 squared. Minus 6 square root 3. And then that's times xy. So I'm going to have x square root 3 x prime minus y prime over 2 times y, x prime plus square root 3 y prime over 2. Then we have plus 13, and that's times y squared. So x prime plus square root 3 y prime over 2 squared. And then we have minus 16 equals 0. So what do we get to do next? We're not going to distribute first. So before we do this on the board, I have it on my board. I should totally write it on the notes. So I'm going to write it on the notes, but it is on the board for when I scroll and you can't see this anymore. If you ever try to multiply out a binomial squared, there is a shortcut that you should have learned in Algebra 2, and it's a squared plus 2ab plus b squared. Or if it's x minus or a minus b, then it would end up having a minus sign here. It's like the only difference if it's minus. So if you know this formula, it's going to take you a little bit less time to multiply stuff out, because I had a couple things squared, a couple binomials squared here. So I'm going to use that formula. So the next thing I'm going to do is multiply the numerator and denominators of the fractions. So I'm going to leave my 7 out there. I'm going to multiply, I'm going to get 3x prime squared. And then my AB term is going to be minus 2 square root 3 x prime y prime. And then my third term will be plus y prime squared. And then in the denominator, 4. That's the first fraction. Minus 6 square root 3. Then these I just have to FOIL together. So I'll have square root 3 x prime squared plus 3 x prime y prime minus x prime y prime minus square root 3y prime squared. Over 4. Then I've got plus 13, and the top is squared, so I'm going to use that formula. So I'll get x squared, x prime squared, plus 2 square root 3 x prime y prime, plus y prime squared over 4, minus 16 equals 0. So when I got to this part, I thought the first 3 terms, or however you want to call them, the first 3 chunks are all divided by 4. So what I'm going to do is I'm going to factor out that 1/4 so I don't have to deal with it right now. Okay. I'm not even taking it out of the 16. The 16 is just getting subtracted by 16 each time. I'm just ignoring that till later. But I'm going to take out that 1/4. And then I'm going to go ahead and distribute the 7 and distribute the square root, or 6 square root 3, and distribute the 13 and write what I have. But I'm also thinking ahead, and I am going to have some like terms. Ooh, I forgot to combine like terms right here. This is 2x prime y prime. I'm going to have some like terms as I multiply all this stuff out. So I'm not going to just make it in one really big line, because then I make more mistakes that way. So I'm going to put the like terms on top of each other as I find them, if that makes any sense. So what I'm going to do is I'm going to distribute the 7 here, and I'm going to get 21 x prime squared minus 14 square root 3 x prime y prime plus 7 y prime squared. Then my next one, I'm multiplying this 6 square root 3. So that's going to give me 6 times 3, negative 18. And that's also an x prime squared. So I'm just putting it underneath the first x prime squared. And then I've got this 2x prime y prime multiplied by minus, so minus 12 square root 3 x prime y prime. And then I'll get positive 18 y prime squared. Now I'm going to do that with the third one, but it's on my paper. I mean, it's up there too, but it's on my paper, so I'm not going to keep going back and forth. So I get 13 x prime squared plus 26 square root 3 x prime y prime, and then plus 39 y prime squared. Minus 16 equals 0. So I'm going to collect those like terms. I'm just going to add them vertically so I don't make any silly mistakes. So I'm going to get 1/4. And I add those up and I get 16 x prime squared. When I add up my x prime y primes, I get 0. So we don't have an x prime y prime term. And that's one reason why we're doing this. Okay, so if you still have an x prime y prime in it, something's wrong. That has got to cancel out. And then plus, add all those up and I get 64 y prime squared. So go ahead and distribute that 1/4 back in. So 4x prime squared plus 16 y prime squared minus 16 equals 0. So we want this to be in standard graphing form of an ellipse. Is it? No. What should we do? Add the 16. Is it in the correct graphing form for ellipses? Nope. We got to divide everything by 16 because it's got to say equals 1. So I get x prime squared over 4 plus y prime squared over 1 equals 1. That's the tedious part. That's the part that takes forever. Okay? We're still not done with this. We have to sketch it. But that's the equation we're going to sketch. I wonder if there is, I'll look later. I was wondering if they have like some sort of pre-made rotated conics graph paper, so you guys don't have to like draw the lines yourself and do them really uneven. I'll look, and if so, I'll post some. Okay, so let's draw XY. And then this is going to be what angle? Pi over 6, 30 degrees. So I'm just going to try to make it 30 degrees. I have to move it a little bit. I'm just trying to make mine look like as accurate as I can for you guys. When I draw the next one, am I going to make it 30 degrees from the x-axis? Will that make, if I do 30 degrees from the x-axis, is that going to make rotated axes? Does that look correct? What's wrong about it? It's not 90 degrees. They have to be perpendicular. So I actually am going to make one that's 60 degrees when I do my other one. Just have to move it. It's close. It'll be 30 degrees rotated past the 90. So I have my x-axis and my y-axis, and then I've got my x prime and my y prime. So with the ellipse, we've got those major vertices, which you guys notice that your book just calls them vertices. And then your book calls them co, or is it the worksheet calls them co? Was it the worksheet that I don't know. It depends like what book it's from. X1 is 30. X prime, sorry. X prime is 30. And then Y prime is like 30 past the Y. So I ended up making like a 60 degree from the x-axis. Okay. So we can find our vertices and our co-vertices in the X prime, Y prime system. I'm keeping it blue because that's the system I'm using. So my vertices, I'm going to use A is 2 and B is 1. A is with the X's. So we're going to change. Oh, where's our center? Center? Thanks, guys. 0, 0. And then the vertices will be plus minus 2 from 0, 0. And then the co-vertices, those would be 0 plus minus 1. And that's in the X prime, Y prime system. So I'm approximately draw that. So I've got my major and my minor endpoints. I just want to make this look like the best ellipse I can make. I think that was a good one for me. It's hard to draw that on the computer. So our theta right here is the 30 degrees, or the pi over 6. This is what I was saying before. This one is 60 degrees right here. So now what we're going to do is we're going to find these points in the XY system. We're going to find the ordered pairs in the XY system. That's all we have to find, our ordered pairs here. How can we do that? How did we do it before? How can we do that? Gavin? Yes, you can totally use the conversions you found earlier. So that will work. I'm going to show you something else that you could do. Because this was a 30-degree angle, and because I am trying to find this point right here by going regular X, regular Y, and this is a 30-degree angle, I know ratios of these sides already. I know that this hypotenuse is too long because I got that from graphing the original vertices. And if this is 2, then this has to be square root 3 and this has to be 1. So if you know your special right triangle like formulas, since this is a 30, I could find it that way. Okay. You don't have to do it that way. You can plug it into the conversion the way we did the first question, but I just want to show you other options. So if I do it this way, my vertices, this one would be at square root 3, 1. And then my other major vertex over here, this is another 30 degree. This is also 2. So this one would be -1, and this would be negative square root 3. So negative square root 3, -1. So those would be the vertices in the regular XY plane. And then the co-vertices or the minor vertices. When I go to get here, if I make that into a triangle where I find my X and my Y, that's a 60 degree and the radius is 1. So that's just like a unit circle, radius 1. The X is the cosine, the sine, the Y is the sine for 60 degrees. So this would be radical 3 over 2, and this one would be 1/2, only negative. And then same thing for this one here. This is going to be a 60 degree with a radius of 1. So that's like the unit circle. And our X and our Y would be the sine and cosine at 60 degrees. So this would be negative square root 3 over 2, and this would be 1/2. Okay. We're done with example 2. Is it fried yet? Yep. Sorry. Do you want to play a really fast game for brain break? Not the one you have to get out of your seat for, though. We don't have a lot of time for that. Okay. Let me pause this video. Example 3, it tells you that we're sketching a parabola. All right. Just so we don't get totally lost. I'm going to start with what? A, B, and C. A is 1. B is -4. C is 4. Cotangent to theta is 1 minus 4 over -4, which is 3/4. It'll be negative, negative, so positive. So where is cotangent equal to 3/4? It's not a special one. So that one's not a special one. So I've like written down 2 different ways of how we could do it, but just time-wise, I don't think I'm going to be able to show both. So I'm going to show you the way that the book did it. They went back to chapter 5, identities. And they pulled out an identity that is for cotangent to theta, which is a double angle identity. That is equal to cotangent squared theta minus 1 over 2 cotangent theta. So they're using that. So that came from chapter 5. So since cotangent to theta is equal to 3/4, I'm going to set cotangent squared theta minus 1 over 2 cotangent theta equal to 3/4, and I'm going to cross multiply. If you are on your phone in class, I assume you know how to do this, and I would love for you to come take it over for me. It's a lot of writing and explaining. I have to talk a lot. No takers? Not yet? Okay. All right, the next one. So I cross multiplied, and it looks like I have a squared theta, and then I also have just the regular cotangent theta. So I'm going to set it equal to 0 and see if we can factor it. Oops, not plus. And for time's sake, it does factor. This is how it factors. 2 parenthesis 2 cotangent theta plus 1 times cotangent theta minus 2. So I get cotangent theta equals negative 1/2, and I get cotangent theta equals 2. So I mentioned this earlier. That's 2 different angles. And you can use either of the angles. But I'm going to try to make less mistakes on all my work. So I'm going to use an angle, if I can, that has positive values. So if I use this cotangent, that would put me either in the 2nd or 4th quadrant. And if I use this one, it's the 1 and 3rd quadrant. Those would be the 2 axes. One of these answers is going to give you 1 axis. The other one's going to give you a different axis. Okay. So both of them are used in this answer, but we tend to try to use the one that's in the 1st quadrant if possible, because it's just going to be easier to have just positive numbers in the 1st quadrant. So I'm going to not use this one. I'm just going to use this one because I know that's going to give me a possible 1st quadrant answer. So cotangent theta equals 2, or tangent theta is equal to 1/2. So I do inverse tangent 1/2 on my calculator. And my theta is approximately 26.6. I forgot now. Oh, wait, I have it written down. 26.6. What's up, Christopher? So you don't have the angle. Oh, you're talking about doing inverse. Probably could. This is the way that they did in the book. So this is not even the way that I did it. Okay. Mm-hmm. So what is it? 4/3, right? So that's not, did you say inverse tangent 4/3? That's not the, that's not, oh wait, I think I'm in radian. Let me try that again. Yeah, so that gives you the exact same answer. So there, you have a shortcut. Okay. And I did think about doing that, but I did it a different way. And if you guys want to know the other way that I did it, you can find out later. But once we have the theta, we know how much it's going to rotate. Now what we need to do is find what x and y equal. So I'm going to go over and write the formulas, and then we're going to realize, oh, we don't have that information. So I'll show you how to find that information. So the x formula is x prime cosine theta minus y prime sine theta. And then y is x prime sine theta plus y prime cosine theta. So with this, the problem is if I type this all into my calculator, I'm going to have horrible decimals, and we're going to do an exact. We're going to find it exactly. So instead of using 26.6, I'm going to use this information to just make a triangle. That's in my first quadrant. Has an angle of theta. The cotangent is 2, or the tangent is 1/2. So I'm going to label my sides 1 and 2, my x and my y. I'll find my radius, or hypotenuse. What is it? Pythagorean theorem. Square root 5, right? So knowing that cotangent of theta is making this triangle, now we can find the cosine of theta is 2 over radical 5, and the sine of theta is 1 over radical 5. So it doesn't even matter that I'm not using that approximation of theta. I just need to know the sine and the cosine for these formulas. So that's what I'm going to use to plug in these formulas, is the cosine of theta and the sine of theta. So I'll have x equals x prime. The cosine of theta was 2 over square root 5 minus y prime. The sine of theta was 1 over square root 5. And then I'll combine that, and I will get 2x prime minus y prime over square root 5 for x. And then for y, x prime plus 2y prime over square root 5. And then we have our x and y values. What should we do next? Substitute x and y in the original equation. So I'm going to have 2x prime minus y prime over square root 5 squared minus 4 times 2x prime minus y prime over square root 5 times x prime plus 2y prime over square root 5 plus 4 times x prime plus 2y prime over square root 5 squared plus 5 square root 5 times x prime plus 2y prime over square root 5 plus 1 equals 0. So that was me substituting in the x's and the y's in the entire equation. So what are we going to do next? Try to say it without smiling. What are we going to do next? Just kidding. You should be saying it like, oh. Ava, do you know what? Yeah, like multiply all that out. Combine like terms. Simplify. Okay, I'm not going to make you do that this second. You're going to have to do it in your work. You can do it. You can do it. You're already done? Okay. So I've already done it. In the book, I had to do it myself. In the book, they literally go from this step to the next step. I'm like, no, I need steps. So I have all the steps if you want to try it and you get stuck. But after you multiply all of this out and combine like terms, we end up with 5y prime squared plus 5x prime plus 10y prime plus 1 equals 0. 5y prime squared plus 5x prime plus 10y prime plus 1 equals 0. Notice how we don't have an x, y. We don't have an x prime, y prime. That was the goal of doing all of this, is to not have that x, y term. So now this is a parabola. We need to put it into that standard graphing form of the parabola. So we have the x's on one side, the y's on the other. So I will go ahead and boot my x's to this side and leave my y's. 5y prime squared plus 10y prime on the right side. I mean, on the left side. I don't know my directions. It's a problem. What am I going to have to do on the left side? Why do I need to factor out of 5, which is correct? Because we need to complete the square. And we cannot complete the square if that 5 is in front. I'll factor it out. So I'll have y prime squared plus 2y prime plus, when I complete the square, that'll be a 1. But when I actually fill it into the square, it's not going to be a 1. What will it be? It'll be a 5, right? I'll multiply that 5 back in. So then we will factor and we'll get y prime plus 1 squared equals negative 5x prime plus 4. This is not the format of the standard graphing form. Does anybody know what is wrong with this form that makes it not the form that we were doing? The x is not factored out. There's something else. Or not the x factored out. I mean the negative 5 factored out. What's going on back there? The 5 that is on the side with a y can't be there. So I'm actually going to divide both sides by 5. So now I have y prime plus 1 squared equals, and on this side I have negative x prime plus 4/5. So then that last step I'm going to do is factor out that 4p value, which ends up being just negative 1. And this would be the standard graphing form of the parabola. But it said to sketch it, so we're not done yet. So what information should we get from this in the XY? Oh, X prime, Y prime plane. What? Oh, the vertex. So the vertex is going to be 4/5. -1. Now, my line, the rotated axes are 26.6. Oh, there we go, yeah. So since I'm using Cami, I can somewhat be accurate. So for the other way, it's not going to be 26.6. Be like 53 point. 53? Oh my gosh, somebody do math. Oh, 63.43. There. So if I have some lines on my X prime, Y prime plane, and this is at 4/5, so about 4/5. Oops, forgot. 4/5, but -1, so it's about there. Which direction would this parabola open? Left because of the y squared. We could find more information like what do we really need to go that way? Huh? R. So P would be -1/4. So our vertex, if we're going to the left, then I'll add that -1/4 to my 4/5. Not the vertex, the focus. Right? Just wrote the wrong number. Oh my gosh. I gotta start that over. -1/4, right? It's like 11/20. So just over half. Somewhere over here. And then how do I find how wide it goes? I need to do 2p, which is, half. And then we're going to add and subtract that from the focus to the opposite number, yeah. So I'll be adding and subtracting that here. So we'll have the endpoints at like 11/20, right? 11/20, and then it'll go up or down, yep. So -1/2 or 11/20, -3/2. This is totally just eyeballing here. So we have an approximation for our parabola. I could also find maybe X or Y intercepts if I want to, really make it accurate. All that stuff that we learned, you can do that. Let's just find the vertex only in the regular XY plane. Let's just find the vertex in the regular XY plane. So what am I going to use to find the vertex? This original X and Y conversion. So the vertex in blue is 4/5, -1. So in black, the x part is going to be 2 times 4/5 minus -1, so +1, over square root 5. That ends up being 13 over 5 square root 5. The y value is going to be 4/5 plus 2 times -1 over square root 5, which ends up being -6 over 5 square root 5. Terrible looking numbers. So the vertex would be at 13 over 5 square root 5, comma, -6 over 5 square root 5. That's what this point is. And we can find that as a decimal and see if it makes sense with the picture. That first one is about 1.16, and then -0.5354, something like that, which I don't even have these labeled yet, but I mean, that seems like it could be right to me. So, oh my gosh, the most fun, amazing lesson ever. Yeah?